Hello friends, in this video we are going to study disk scheduling algorithms. Mainly this disk scheduling algorithms we are using it to minimize your seek time. The seek time what we had seen it in the previous video. As stated in the previous video, it is just a time taken by a read-write head to reach the desired track. Okay, so this is what is the read-write head. So if this read-write head is present on this track, let us assume that this track is the second track, and if I want to reach to the fifth track, so what is the time taken by this read write head to move from a second track to fifth track? That is what is the seek time. That is what we had seen it in the previous video. Okay, so knowing this, today we will be moving to the next part, that is what is your scheduling algorithms. And as stated, these scheduling algorithms are mainly used to reduce the seek time. Okay, so these are some of the scheduling algorithms. We will be seeing all the scheduling algorithms one by one. Okay, so come let's begin with the first algorithm. Okay, so as you can see here, this is the first algorithm, that is this scheduling algorithm FCFS. FCFS means it is first come, first serve. Okay, so seeing at this, let us see this. This is what is the queue. This is how mainly we will be finding some of the problems in your exams on the scheduling algorithms. So they will be given, you will be given with this queue status and what is the head starts at. Okay, so here we are having 200 tracks on a disk. Okay, so which is from 0 to 199. So definitely we are having 200 tracks. So initially our read write head is currently present at which track? It is on the 53rd track. So what is the given task for you now? Which all are the elements which are there on the queue? That is 98, 183, 37, 122, 14, 124, 65, and 67. What are these exactly? These are nothing but your track numbers. Okay, where your read write head should move. Okay, so that means when your read write head is on 53, your command is given that now the read write head should be moving to 98, read the information, and then it should be moving to track number 183, read all the information. Next, it will be moving to track number 37, reads all the information, so on. Okay, so whatever are the numbers which are on the queue, these are nothing but the track numbers. Okay, so as the name states, first come, first serve, whatever the tracks which are there on the queue, that should be served in a sequential manner. Okay, see this diagram over here. Seeing this diagram, what we can make out, let us understand that. Okay, so let me just skip this. Okay, let me just copy this so that I can explain you this on the whiteboard. That would be easy for us. Just okay. So now what we can do here is, oops, it's visible. Okay. Okay. Now what we'll be doing here is, okay. So this is what is the given queue for you, right? So now what we'll be doing, as your read write head is initially at 53, it will start at 53. Okay. So what is the first element in the queue? It is 98. Okay. So now what your read write head will be doing, it will be moving from 53 to 98. Okay. So when your read write head moves from 53 to 98, that means what is the shift over there? Okay, what will be the shift? That is 98 minus 53. Okay, 98 minus 53. That is the total number of shift what your read write head is shifting. Okay, now after 98, what is the next number you are having? It is 183. Okay, let us take your text. We'll try to insert the text over here. Okay, the first one, what we had carried is what? What was the difference over there? It was 98 minus 50, okay, plus. Why I'm doing this plus? I will just explain it here. Why I'm doing this plus? Use this size so that it will be visible for you. Okay. So now, why I have done this plus? I will just explain here. Okay, so here, as you see, initially it was there on 53. Now your read write head should be moving from 53 to 98. As 98 is on the first element which is there on the queue, that means you have to read the information which is on the 98th track. So your read write head is moving from 98 to 53. So what is the displacement? 98 minus 53. Okay, but this is not the only information you have to read. There are some other information to be read. Okay, now the current status of your read write head is that your read write head is on the 98th track. Okay, now what is the second element in the queue? It is 183. That means what is the meaning out of it? As now currently you are on the 98th track, now you have to move to the track 183 so that you can read the information which is present on 183. So what is the total displacement? 98 to 183. That means it is simple 183 minus 93. 183 minus 93. Not 93, it's 98 because you are currently your read write head is on 90. Okay, so is this the end? No. After 183, which is the next element you are having, the next element what you are having is 37. Okay, so now you have to move again to track number 37. So what is the current status of your read write head where it is? It is there on 180. Now from 183, it has to move all along from 183 to 37. So what is the displacement you can give now? The displacement is 183 minus 37. Okay, so this is how it will be calculated. So when you calculate all, okay, when you calculate all, what is the total number of head movements? The total number of head movements is nothing but 640 cylinders. Okay, how did we get this 640 cylinders? If you just go on minusing these values. Okay, as it is on the 53, first is it has to move to 98, that is 98 minus 53 plus 183 minus 98 plus 183 minus 37 plus 37 minus 122. Don't do that, please. Okay, because it will come in minus factor. So that is why what you have to do 122 minus 37. Okay, plus after that, from 122, it is again moving to 14. So 122 minus 14. From 14, it is moving to 124. So it is 124 minus 14 plus from 124, it is moving to 65. See here, it is 65. So 124 minus 65. From 65, it is moving to 67. So 67 minus 65. So when you sum all these values, what is the total answer I am getting? The answer what I am getting is 640 cylinders. That means 640 hops or 640 tracks it is jumping, right? To and fro, that is left and right, it moves on. Your read write head is moving from left to right to left to just to read all the information, whatever is there on the queue. Okay, so this is a simple scheduling algorithm, that is first come first serve scheduling algorithm. Here there is huge movement of this read write head from left to right. Okay, so this is not termed to be as an efficient one. Why? Because your head movements are on a higher side. Your head movements are on a higher side. Okay, so what more we can do that so that we can reduce this efficiency, or we can increase the efficiency, access time, the disk access time can be reduced. Because now if you see, the disk access time is on 640, which is on a higher side. So is there any mechanism to reduce that? Yes. Okay, that is where your next algorithm comes. That is shortest seek time first.